sources of energy. Okay, so see here, this is the second section of unit number 1. That is nothing but introduction to different sources of energy. That is nothing but thermal power plant. Okay, so see here, first of all we will see what is the generating station, or first of all we will see what is the introduction of generating stations. So see here, all of you know that electrical power is produced by a special plants. Okay, electrical power is produced at the different power plants, and that power plants are known as generating stations or a power plant. Okay, so see here, bulk electrical, see that means a large amount of electrical energy is produced by different or special power plants. That power plants are known as generating stations or a power plants. Okay, so see here, these are the power plants which produces a large amount of electricity, are known as generating stations or power plants. A generating station is essentially employs a prime mover. Okay, see here, in every generating station they essentially employ a prime mover. What is the meaning of prime mover? See here, prime mover is a equipment which is coupled to an alternator. Okay, so see here, what is the meaning of alternator? Alternator is an electromechanical device that converts mechanical energy into electrical energy. Okay, that means a device which converts mechanical energy into electrical energy are known as alternator. Okay, so see here, in this alternator input is a mechanical and output is a electrical. So see here, in a generating station output is electrical energy, so that alternator output is also an electrical energy. Okay, but the input of this alternator is a prime, is nothing but a mechanical. Okay, so see here, a prime mover that is coupled with an alternator, that means this prime mover will provide mechanical energy. Okay, this prime mover will provide mechanical energy to this alternator. What is mechanical energy? So see here, n number of mechanical energy are there. Rotation, okay, that means work done. Okay, so these are the mechanical energies. Okay, so see here, this mechanical energy will get converted into electrical by this alternator, and which is coupled with a prime mover and which used for the production of electrical energy or power. Now see here, we will see what is this prime mover. So see here, these prime movers are steam turbine, water turbine, etc. Okay, all of you know that. What is the meaning of turbines? Okay, so see here, whenever the turbine is start rotating with the help of steam is known as steam turbines. Okay, जो turbine steam यूज कर रोटेट होते हैं या फिर स्टीम की वजह से रोटेट होते हैं, दैट विल बी कॉल्ड एज स्टीम, और दोज टर्बाइन व्हिच आर रोटेट ड्यू टू वाटर आर कॉल्ड एज वाटर टर्बाइन. ओके, सो सी हियर, so these two turbines converts mechanical energy. Okay, see here, these turbines converts energy from some other form into a mechanical energy. That means see here, first of all these turbines are there. Okay, now in this turbine input is some another energy. Okay, see here, input is some another energy. That means in the steam turbine, see here, in the steam turbine steam energy is there or heat energy is there in input, but output is a mechanical energy. That means mechanical rotation. So for this turbine, input is a thermal energy and output is a mechanical energy. Now for this, see here, water head, right? Water pressure are there for this input turbine, right? For this input For this water turbine, input is a water pressure and output is a mechanical rotation or mechanical energy. So these two type of prime movers converts any type of energy into mechanical energy and start rotating, and this type of steam turbine and water turbine are coupled to the alternator. So this alternator converts mechanical rotation into electrical power. Now see here, this alternator converts mechanical energy of prime mover into an electrical energy. Electrical energy produced by the generating station is transmitted and distributed with the help of conductors to various consumers. That means see here, this electrical energy produced by generating station is transmitted and distributed with the help of conductors to the various consumers. That is called a power system that we have already seen. Okay, electricity generated at generating station, okay, and that has to be transmitted over the larger distance, and this can be done with the help of different conductors, and after transmission of this electrical power we have to distribute among the various consumers, are known as a power system. So it may be emphasized here that apart from prime mover alternator combination, a modern generating station employs several auxiliary equipments and instruments to ensure cheap and reliable continuous service. That means here, not only prime mover and alternator are there in a generating station, other modern equipments are also there, other auxiliary equipments are there. Okay, and these instruments will ensure that they will provide cheap, reliable and continuous service. That means a number of equipments are there in a power station. Okay, not only prime mover and alternator are there. Okay, so this is about the generating station. Now see here, depends upon the form of energy converted into electrical energy. That means see here, depends upon input. Okay, now see here, depends upon the form of energy which is converted into electrical, the generating stations are classified as. Now see here, if the input of the turbine is an heat energy, if the input of an turbine is a heat energy, that means heat energies get converted into electrical. According to that, these generating stations are classified as, first is a steam turbine, second is a hydroelectric power station, third one is a diesel power plant, and last is a nuclear power plant. So see here, diesel or gas. Okay, now see here, steam energy is the input to turbine, so that turbine start rotating. So the rotation is a mechanical energy, that mechanical energy is get converted into electrical with the help of alternator. Similar way, hydroelectric power plants, that means a dam is there, right, and in that dam high pressure water will be moved towards a water turbine due to the high pressure water, right. See here, high pressure is nothing but one form of energy. That one form of energy is get converted into a mechanical rotation by using the water turbine, so that electricity is generated with the help of alternator. Next is diesel or gas. Similar way, diesel and gas are the input to the turbine, okay, and that converts these energies into an electrical energy, and that electrical energy will be utilized for the that is utilized for the that is used for the utilization of different kinds of load, that is commercial as well as agricultural as well as domestic as well as industry loads. Okay, similar, and the last power plant is a nuclear power plant. Okay, now we will see all these 4 power plants in this unit. We have to see all these power plant in this unit. So first is a steam power plant that we have seen in a practical number 1. Second, hydroelectric we have seen in a practical number 2. Now we will see nuclear. Okay, first we will see nuclear, and after that we will see diesel or gas. Okay, so see here, now we will move towards nuclear power station. So in this lecture we are going to start nuclear power station. We will move towards nuclear power stations. So first of all we will see introduction about nuclear power station. A generating station in which, first of all, wait, am I audible? Am I audible?
Yes, sir.
Yes.
Yes, sir.
Yes, sir. Yes, sir.
Okay. So we will first of all we will see nuclear power stations. So see here, a generating station in which nuclear energy is get converted into electrical energy is known as a nuclear power stations. Okay. So see here, for turbine, nuclear energy is input. Okay. So due to this nuclear energy, wait. Okay. Now for this generating station in which nuclear energy is get converted into electrical energy, that means for turbine, right? For turbine, see here nuclear input. That means see here in a nuclear reactor is there. In that nuclear reactors, nuclear energy is there. That nuclear energy is get converted into a mechanical rotation of that turbine, and that if the turbine start rotating, that turbine is get coupled with an alternator. So this alternator will convert this nuclear energy into electrical energy. That is happen in a nuclear power stations. That means the generating station where nuclear energy is get converted into an electrical energy is known as a nuclear power station. So in a nuclear power station, heavy elements such as uranium, okay, see here some heavy elements are there, that is nothing but uranium. Now tell me, this is atomic number or atomic mass number? Tell me. Can anybody tell me what is this? U-230,
Atomic number.
235, what is the meaning of this?
Atomic mass number.
Okay. So see here in a
Mass.
nuclear power station, heavy elements such as uranium, that is nothing but U-235, and thorium, that is 232, are subjected to a nuclear fission in a special apparatus known as reactor. Okay, now see here some nuclear fission is there, right? And this nuclear fission will be happen to an heavy element such as uranium or thorium. Okay, एक तो यूरेनियम यूज करना है या फिर थोरियम, राइट? एंड these heavy elements are subjected in a reactor for nuclear fission. Okay, so if this nuclear fission is happen in a nuclear reactor, the heat energy thus released, and this is utilized to raise the steam at high temperature and pressure. That means see here some tubes are there, and in that tube water is provided, right? And the heat produced due to the nuclear fission will be moved towards this boiler, right? And after that this water get converted into a high temperature and high pressure steam. Now this high pressure and high temperature steam will be run towards the steam turbine. Okay, And now this steam turbine which converts steam energy into a mechanical energy. What is mechanical energy? The rotation of this turbine, right? Rotation of this turbine will be nothing but a mechanical energy. Now this rotation or rotated steam turbine drives the alternator which is converts mechanical energy, that is nothing but rotational energy into an electrical energy. The most important feature of nuclear power plant is that huge amount of electrical energy can be produced from a relatively small amount of nuclear fuel. Okay, so see here, this is the most important feature. That means we can produce huge amount of electrical energy, right? And that will be produced from relatively small amount of nuclear fuel as compared to other conventional type of power plants, that is nothing but hydroelectric, gas and thermal or steam. Okay, so see here, this steam, hydroelectric and nuclear have used relatively large amount of fuels for production of huge amount of electricity, but as compared to this power plant, nuclear will use small amount of nuclear fuels for the production of huge amount of electrical energy. It has been found that complete fission of 1 kg of uranium can produce as much as can be produced by burning of 45,000 tons of high grade coal. That means see here, there is a comparison between coal based power plant and nuclear power plant. Now see here, if we have burned 4,500 tons of high grade coal, that means here bituminous is a high calorific value. Okay, so see here, calorific value of high grade, see here, high grade coal means having an high calorific value. Okay, means जो ऐसे कोल है जिनकी कैलोरीफिक वैल्यू, दैट मीन्स बर्निंग कैपेसिटी बहुत हाई है. ओके, दैट मीन्स हियर नॉट दैट मीन्स they can totally burn, right? That is called a high grade coals. So these high grade coals will be used, that is how much amount of these high grade coals are used, that is 4,500 tons is used for the production of X amount of energy. Okay, now see here, if we have to produce X amount of energy, for that purpose coal based power plant will use how much amount of coal, that is 4,500 tons. Okay, but instead of using this amount of tons, if we have used 1 kg uranium, okay, in a nuclear power station, same amount of power or energy is produced by this nuclear power station. That means see here, कोल बेस्ड पावर प्लांट में इतना ज़्यादा कोल यूज़ करते हैं हम, दैट इज़ 4,500 टन्स कोल यूज़ करते हैं, और इतना सब यूज़ करने के बाद हमें जो एनर्जी मिलती है वो एनर्जी सेम एनर्जी है, दैट एनर्जी हैज़ बीन प्रोड्यूस्ड बाय 1 kg ऑफ यूरेनियम, दैट इज़ कंप्लीट फ्यूजन ऑफ 1 kg ऑफ यूरेनियम इन अ न्यूक्लियर रिएक्टर. दैट मीन्स सी हियर, only 1 kg uranium can produce same amount of energy that can be produced by burning of 4,500 tons of high grade coal. That means this nuclear power plant can produce huge amount of power for relatively small amount of nuclear fuels. Okay, now we will move towards next part of a nuclear power station, that is this nuclear power station, although the recovery of principal nuclear fuels, that means it uses the principal nuclear fuels, that is uranium and thorium. Now it is difficult, these fuels are difficult and expensive, yet to total energy content of the estimated world reserve of this fuel are considerably higher than those of conventional fuels. That means here these nuclear fuels are difficult and these are having expensive, okay, and these are considerably higher than those of conventional fuel, for example coal, oil and gases. Now at present energy crisis is gripping up and therefore nuclear energy can be successfully employed for the producing low cost electrical energy on the large scale to meet growing commercial and industrial demands. That means here nowadays commercial as well as industrial demand is growing, okay. Now there is an energy crisis are there, so to overcome all these things we have to employ a nuclear energy, and this nuclear energy can produce a low cost electrical energy at a larger scale, okay. We will see what is the advantages and disadvantages of this nuclear power plant, okay. Now first of all we will see what is the advantages of this nuclear power plant. So see here these are the advantages. First advantage, the amount of fuel required is quite small. Therefore there is a considerable saving in the cost of fuel transportation, right? So see here if we have used the coal, so see 4,500 tons coal is there, so we have to move this 4,500 coal tons from coal mines towards our power station. That means transportation cost is there. So if instead of coal we have used nuclear power station, so there is a small amount of fuel is required, and if we have required small amount of fuel, that we can save the cost of fuel transportation. So this is the advantage of our nuclear power plant. Next advantage, a nuclear power plant require less space as compared to any other type of the same size power plant. Now see here same size of power plant, that means see here one steam turbine is having rating, right? If suppose capacity, if any power plant is having capacity 100 megawatt, okay, so see here space required for that coal based 100 megawatt power plant is larger than a nuclear power plant, okay. That means see here same rating of power plants are there, nuclear as well as coal, but coal require larger space as compared to nuclear. That means nuclear require a less space. First require less fuel, next require less space. Now third advantage, it has low running charges as small amount of fuel is used for the production of bulk electrical energy. Now see here we are going to use only the less amount of fuels, right, so that running cost or running charges is less in nuclear power plant as compared to another power plants, okay. So this type of power plant is very economical for producing, wait, okay. So this type of power plant, what happened? Is there any problem? Yes or no? Please tell me. Shall we move forward?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So
Yes,
this type
sir.
of power plant is very economical for producing bulk amount of electrical powers. Okay. First four advantages. First is less fuel requirement, less space requirement, less running charges. It is economical for producing bulk amount of electrical power. Okay. Now next, it can be located near the load center because it does not require large quantity of water. Right. See here, this power plant does not require a large quantity of water, so that it can be located near the load centers. Okay. So there is a no need to be build the power plant near the coal mines. Okay, see here, if the coal power plants are there, we have to build the power plant near the coal mines, right? Because we have to reduce the transport transportation cost in the coal power station, so that we have built the power station near the coal mines, right? But in this case of nuclear power plant, there is no need. Okay, there is no need to build the power station near the resource center, right? Source center. So instead of building these near the source center, we have to build or locate our power plant near the load center. Okay, so therefore the cost of, wait, so therefore the large deposits of nuclear fuels available all over the world, therefore such power plant can ensure continued supply of electric energy for thousands of years. That means here, these nuclear fuels are there, right? And these nuclear fuels are available all over the world, so that these nuclear fuels can continuously provide us, these nuclear fuels can be continuously provide us energy for the 1,000 years. Okay, wait, just wait for 1 minute. Now see here, the fifth advantage. First, we can locate our nuclear power station near the load center. Okay, next, these nuclear fuels are available in the world, right? These nuclear fuels are available all over the world, so that these nuclear fuels can be used, and this nuclear fuel can provide us an electricity for 1,000 years. Okay. Now see here, we know that coal are not available everywhere. Okay, and the reserve and the coal is the as well as the coal. Who is this? Okay. Now see here, coal, सॉरी, फर्स्ट ऑफ ऑल न्यूक्लियर पावर स्टेशन जो है, उसके जो न्यूक्लियर फ्यूल्स है वो हर जगह मौजूद है। उसके हिसाब से हम अगर वो यूज़ करते हैं तो हमें लार्ज अमाउंट ऑफ इलेक्ट्रिसिटी और बहुत टाइम के लिए, दैट मीन्स 1,000 ईयर, वो हमें सप्लाई कर सकती है। बट इन केस ऑफ अगर हम कोल यूज़ करते हैं तो हमें पता है कि कोल हर जगह मौजूद नहीं है, राइट? ओनली सम प्लेसेस आर देयर एट विच अ कोल इज फाउंड। ओके, और हमें ये भी पता है कि कोल जो है वो अभी खत्म हो रहे हैं, राइट? दैट मीन्स दिस कोल कैन नॉट बी प्रोवाइड एनर्जी फॉर 1,000 years, राइट? सो दिस इज द अनदर एडवांटेज ऑफ दिस न्यूक्लियर पावर स्टेशन। ओके, and the last advantage of this nuclear power station is It ensure reliability of operations. Okay, that means here these are the 7 advantages of nuclear power station. So see here in your exam, they can ask the advantages about the nuclear power station. So we will see what are the now again we will see what are the advantages of our nuclear power station. First advantage is nothing but small amount of fuel is required. Second is less space is required, less running cost. It can produce, sorry, it is economical and it can produce a bulk amount of energy. It can be located near the load centers. Next, nuclear fuels can available all over the places, so it can produce or it can supply electrical power for thousands of years. And last is nothing but it ensures reliability of operations. Okay, now we will move towards disadvantages. So see here, these are the disadvantages of nuclear power plant. First disadvantage, the nuclear fuels used in the nuclear power station is expensive and is difficult to recover. Okay, so see here, first disadvantage, these fuels are expensive and these are difficult to recover. Next, the capital cost on nuclear power plant is very high as compared to other type of power plants. So see here, only capital cost of this nuclear power plant is high. Okay, because running cost is less. Only capital cost of this nuclear power plant is high. Why? Because these power plant uses expensive fuels, so that the capital cost of this power plant is high as compared to another power plants. Next, the erection and the commission of the power plant require greater technical knowledge. That means see here, when we are going to implement a nuclear power station, then there is a greater technical knowledge are there or expert persons are there for the commissioning of the power plant. This is the disadvantage of this nuclear power plant. Next, the fission byproduct. Now see here, we know that thorium having the nuclear fission in a nuclear reactor, and it will produce a heat, and that heat is used for the production of electrical energy, and this fission is also provide some byproducts. Okay, similar ways here, जब हम coal burn करते हैं, so that coal can provide a heat, right? coal burn करने के बाद coal heat भी provide करता है और उसका बाय प्रोडक्ट प्रोवाइड करता है, दैट इज फ्लू गैसेस. ओके, सो सी हियर फ्लू गैसेस में हम क्या 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 आता है, ऐश भी आता है, राइट? ash is also there, as well as some gases is also there. Okay, so similar way, whenever we are Okay, screen is visible. Now my voice is clear.
No.
Now my voice is clear. आवाज येता है सगळ्यांना?
Yes, sir.
Yes,
हाँ
sir.
सर येत आहे.
Yes, sir.
Yes,
Okay.
sir.
Now we will see the disadvantages. Okay. So see here, next disadvantage of this power plant is it requires high maintenance cost. Okay, because some skilled persons are there, right? And this skilled person can handle the power plant for the maintenance purpose, so that so that high amount of salary has to be paid to this skilled person, so that maintenance charges of this power plant is higher. These nuclear power plants are not well suited for varying loads. Now see here, if there is a varying load, right, these nuclear power plants are not suited as, see, please mute your mic. Next disadvantage, these nuclear power plants are not well suited for varying loads as the reactor does not respond to the load fluctuation efficiently. That means see here, whenever there is a load fluctuation, okay, whenever there is a load fluctuation or a varying load, the nuclear reactor is not performing efficiently, so that these nuclear power plants are not well suitable for the varying load. That means if suppose we have already seen that there is a national grid is there, in that national grid n number of power stations are connected, right? Now if suppose there is a base load, so this base load can be supplied by nuclear power plants. Why base load is supplied by nuclear power plant? Because these base loads are not in a varying nature. Okay, these base load, we have already seen that what is the meaning of base load? The load which is appear for 24 hours. Okay, जो लोड 24 आवर अपीयर होता है, दैट विल बी कॉल्ड एज बेस लोड. दैट मीन्स बेस लोड में वेरिएशन नहीं रहती है, सो दैट न्यूक्लियर पावर प्लांट कैन बी सूटेड फॉर प्रोवाइडिंग द बेस लोड्स. ओके, and last disadvantage, the disposal of the byproducts which are radioactive is a big problem. So they have either to be disposed of in a deep drain or in a seaway from a seashore. That means here byproducts is a radioactive material, right? First byproduct is a radioactive material. This radioactive material can produce radioactive pollutions. Okay, and there is also one another problem, that is we have to dispose, right? We have to dispose this radioactive element. So this is a big task or big problem, right? So this radioactive element can be disposed of in a deep trench or in a seaway away from the seashore. That means these are the two techniques for disposal of the byproduct which is produced by nuclear power plant, that is nothing but an radioactive elements. So these are the advantage and disadvantages. Now we will see what is the schematic arrangement of this nuclear power station. So see here, the schematic arrangement of nuclear power station is shown in the next slide. The whole arrangement can be divided into the following main stages. Now see here, in next slide there is a schematic arrangement of nuclear power plant, and this schematic arrangement can be classified into these main stages. Now see here, there are four main stages are there in a nuclear power plant. First stage, nuclear reactor. Second stage, heat exchanger. Third stage, steam turbine. And last is an alternator. Okay, now see here, these are the four important stages are there in a nuclear power station. So first stage is nuclear reactor, where nuclear fission is happen, right? Due to this nuclear fission, heat is produced. Now this heat energy has to be exchanged to the water, right? Now that for that purpose, heat exchanger equipments are there, right? Now in that heat exchanger equipments, heat is exchanged that so that due to the heat exchanger, water get converted into steam. Now this steam has to be moved towards steam turbine. So next important stage is a steam turbine. If the steam turbine moving towards the steam turbine, if the steam is moved towards the steam turbine start rotating. This steam turbine is get coupled with an alternator, so that alternator start rotating. So alternator can produce or can convert steam energy into an electrical energy. So these are the 4 important stages in a nuclear power plant. So first is nuclear reactor, where the nuclear fission is there. Next, heat exchanger, heat has to be exchanged. Next, if heat is exchanged, steam is produced. That steam has to be moved towards steam turbine. And last is alternator, where the electricity is produced. We will see. Now see here, this is the schematic arrangement of nuclear power station. So see here, this is the first stage. This is the first stage where nuclear reactor is there. This is the second stage where heat exchanger is there. Now this is the third stage where steam turbine is there. And this is the last stage where alternator is provided. Okay. Now see here, this is the schematic arrangement. Okay. Now we will move towards, now we will study in detail about this schematic arrangement. Okay. Now we will see one by one stages. Okay. Now first we will see what is the nuclear reactor. Okay. So see here, it is an apparatus. Nuclear reactor is an apparatus in which nuclear fuel is subjected to a nuclear fission. Okay. See here, nuclear reactor is an apparatus where nuclear fission will be takes place, and that means this nuclear reactor can control chain reaction at start once the fission is done. Okay. Now see here, what is the purpose of this nuclear reactor? First, it has to produce or it has to provide a nuclear fission, and after that it has to control a chain reaction. If the chain reaction is not controlled, the result will be an explosion due to the fast increase in the energy released, right? So see here, nuclear reactor plays an important role to control the chain reaction. If chain reaction is not controlled, it will result in the explosion. Okay, so this is the nuclear reactor. So nuclear reactor is an apparatus in which nuclear fuels like uranium, thorium is subjected for the nuclear fission. This nuclear reactor can control the chain reaction that starts once the fission is done. Okay. 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 It will control the chain reaction, right? If the chain reaction is not controlled, it can produce an explosion in the power station, and this explosion will be or due to the fast increase in the energy released. Okay, this nuclear reactor is a cylindrical stout pressure vessel, and it uses fuel rod of uranium, moderator, and control rods. Okay, that means here this nuclear, first of all, this nuclear reactor is a cylindrical stout pressure vessel, right? And it uses a fuel rod of uranium, moderator, and control rod. That means 3 rods are there in this nuclear reactor. Now the fuel rods constitute the fission material and release huge amount of energy when bombarded with a slow moving neutrons. The moderator consists of graphite rod which enclose the fuel rods. Okay, the moderator slow down the neutrons before they bombard into the fuel rods. Now see here, first of all, we will see the internal structure of the nuclear reactor. So nuclear reactor is made up of cylindrical sprout. Okay, wait. Okay, first of all, this nuclear reactor is made up of cylindrical spout, pressure vessel, and it uses three rods, that is uranium, moderator, and control rods. Okay. Now see here, first of all, it uses fuel rods of uranium, moderator, and control rod. That means see here, this this nuclear reactor uses fuel rods, and which is made up of uranium, moderator, and control rods. So this, first of all, this fuel rod constitute the fission material and release huge amount of energy when bombarded with a slow moving neutrons. Next, this moderator consists of graphite rod which enclose the fuel rod. Right. Next, the moderator slow down the neutrons before they bombard into the fuel rods. Okay. See here, this nuclear reactor figure will be shown in the next slide. The control rods are of cadmium inserted into the reactor. Cadmium is a strong neutron absorber and thus regulate the supply of neutron for fission. When the control rod are pushed into the deep enough, they absorb most of the fission neutrons and hence few are available for the chain reaction, right? And which can be stopped by using a nuclear reactor. Now see here, these are the structure, right? These are the internal structure of nuclear reactor. Now see here, this nuclear reactor, I have already told you that these are looking like a vessel. So in that vessel, see here, some control rods are there and some moderator rods are there. That is nothing but graphite rod are there and some uranium rods are there. Okay. So see here, this black color is a uranium rods. These are the moderator or graphite rods and these are the control rods. Okay. So however, as they are being withdrawn, more and more of this fission neutron cause fission and hence the intensity of chain reaction is increased. Okay, now see here, whenever there is a fission of neutron, right? Whenever there is a fission of neutron, that causes the intensity of chain reaction has been increased. So therefore, by pulling out the control rods, right? If suppose we have to control the intensity of this, right? We have to control the intensity of chain reaction. We have to pull out this control rod, right? So power of the nuclear reactor is increased, whereas by pushing them, it will reduce. That means here, when this control rod will pull out, right? When this control rod will pull out, it will increase the power of nuclear reactor. When it will push inside, it will reduce the power of nuclear reactor. In actual practice, the lowering or raising the control rod is accomplished automatically according to the requirement of load. Okay, the heat produced in the reactor Now the heat produced in the reactor is removed by coolant and generally a sodium metal the coolant carries the heat to the exchanger. Now see here, the heat is produced. Okay, now this heat will be moved towards here. That is nothing but a heat exchanger is there. Now here is a heat exchanger. Now see here, in this heat exchanger, first tubes are there, and in that tube steam is moved, right? Now due to this steam, no, sorry, there is a heat energy, right? Now this heat energy, will convert this water into a steam. Now this steam will be moved towards the steam turbine. So this is the structure or the working of the nuclear reactor. Okay. Now next, that is nothing but heat exchanger, and the remaining things we will see in the next lecture. Okay. Now is there any problem regarding nuclear reactor or nuclear power plant? Is there any problem? Yes or no, please tell me.
No, sir.
Okay,
No,
if there
sir.
any problem, if there is any problem, we will see in
No,
tomorrow's
sir.
lecture at 10:30. Okay. जर काय प्रॉब्लेम असेल तर आपण उद्या 10:30 च्या लेक्चर मध्ये बघूया. ओके. नाउ वी विल स्टॉप हियर.
Okay, sir.